You wanna sit low on my living room floor, play Nintendo with Seasonino. Pick up my phone, say Papa not home. Sex all night, mad head in the moon. Spin my beat, smoke all my weed. Tattoo on TT saying B.I.G. Now check it. You wanna be my mint squeeze, baby?
So I'm going to do some examples for limits and continuity. So example 1 is find the limit as xy approaches -1, -2 of x squared minus y squared over 2xy plus 2. So we just plug in -1 and -2 for x and y. We get -1 squared minus -2 squared over 2 times -1 times -2 plus 2. This is just 1 minus 4 over 4 plus 2, which is -3 over 6, which is -1/2. So if plugging it in works, then that's your limit. So the next example is we're going to show that this is discontinuous, or that this limit does not exist. So we're going to evaluate it along the positive x-axis and positive y-axis. And if the results don't agree, then the limit doesn't exist. So if we're going to go along the x-axis, then we had to first set y. First y has to approach 0. So for any x, y is 0. Then we're going to have x approach 0. So we're going to do this first, then that. So limit as y approaches 0 is going to be on the inside, and the limit as x approaches 0 is going to be on the outside. This is of 3x squared minus y squared over x squared plus y squared. So if we let y approach 0 first, so we're going to have the limit as x approaches 0 out here. So we're going to have 3x squared minus 0, which is just 3x squared, over x squared plus 0, which is just x squared. The x squareds will cancel, and our answer will be 3. But if we're going to go along the y-axis, we first have to have x approach 0, then have y approach 0. So we'll have the limit switched here. X approaches 0 on the inside, y approaches 0 on the outside. And if we let x approach 0, we'll have limit as y approaches 0 of minus y squared over y squared. The y squareds will cancel, and we'll get -1. So 3 doesn't equal -1, so the limit does not exist. So example 3, we're going to do the same thing, but it's going to be a little bit more complicated, our paths. So the limit is xy approaches 0, 0 of 3x squared y squared over x to the third plus y to the sixth. And we're going to evaluate it along y equals mx, so any straight line, and along x equals y squared, so a parabola opening to the right. So I'll draw these. So this will be y equals mx. M is the slope of the line. And this will be x equals y squared. So for paths like these where we're going along functions, we're going to first have, for y equals mx, y will approach mx, then we'll have x approaching 0. And that way, both x and y will approach 0, because mx approaches 0 as x approaches 0. And then for this, we'll have x approaching y squared first, and then we'll have y approach 0, because y squared approaches 0 as y goes to 0. So our first limit will be limit. First, on the inside, we'll have y approaching mx and x approaching 0 of 3x squared y squared over x to the third plus y to the sixth. So we just plug in mx wherever we see y. So we have 3x squared times mx squared over x to the third plus mx to the sixth. And this will just be 3m squared times x to the fourth over x to the third plus m to the sixth times x to the sixth. And if we factor out x to the third from the bottom, we'll have x to the third times 1 plus m to the sixth, x to the third. And x to the third on the bottom will cancel with x to the fourth on top, leaving just x. And, sorry, I should have been writing limit as x approaches 0. And this will equal the limit as x approaches 0 of 3m squared x over 1 plus m to the sixth, x to the third. If you plug this in, you get 0 over 1, which is just 0. So that was our first result. Our second result is if we take the limit as x approaches y squared first, then y approaches 0, of 3x squared y squared over x to the third plus y to the sixth. So wherever we see x, we'll put in y squared. So we have 3 times y squared squared times y squared over y squared to the third plus y to the sixth. And, oh sorry, this should be the limit as y approaches 0. We don't have any x's. So we'll have y to the 6th, 3y to the 6th on top, because y squared squared is y to the 4th, times y squared, y to the 6th. Y squared to the 3rd is y to the 6th, plus y to the 6th. And if we combine the y to the 6th in the denominator, we'll get 3y to the 6th over 2y to the 6th. The y to the 6th will cancel, and we'll have 3 halves. So, since 0 does not equal 3 halves, and I think I should have, 3 does not equal negative 1 up there. 3 halves does not equal 0. The limit does not exist. So now we'll do some continuity examples. So, example 1 for continuity. We want to show f of xy is continuous at 0, 0, and we have f of xy equals square root of 10 plus x squared plus y squared. So, first condition is f is defined at that point, so f of 0, 0 is 10 plus 0 squared plus 0 squared, which is just square root of 10. Now we have to show the limit exists, so the limit as xy approaches 0, 0 of f of xy is just the limit as xy approaches that point of square root of 10 plus x squared plus y squared. Well, in this case we can just plug stuff in, and we'll also get square root of 10. So the limit exists, and the limit equals the function at that point, so f of xy is continuous at 0, 0. So we don't know about any other points, but at 0, 0 it's continuous. So now we're going to show for our next example that we're going to show that g of xy is discontinuous at 0, 0. So now, if any of those conditions up there fail, our function will be discontinuous, and g of xy is equal to 3x squared y squared over over x to the third plus y to the sixth for all xy not equal to 0, 0, and g equals 0 for xy equal to 0, 0. So g of 0, 0 is just 0, according to the definition, and the limit as xy approaches 0, 0 of g of xy equals the limit as xy approaches 0, 0 of 3x squared y squared over x to the third plus y to the sixth. But this is the same limit we did in our limit example right here, and we showed that this does not exist, so that violates our continuity condition. So g of xy is discontinuous at 0, 0.
All you heard was Papa, don't hit me no more.
Now don't be trying to come around my girl acting like Mr. Friendly. It's still the spotlight like Mr. Bentley. I spotted her like Spud McKenzie, and for them fake boobies I paid them Benjis. Get your own.